Hi there. A couple of you guys had sent me emails about finding the LCM or the LCD. And we talked about it in class, but I thought it might be good to take a couple of minutes to go over it again. So we'll take a couple minutes to look at a 2-number LCD and a 3-number LCD. So what we've got up here right now is an LCD that we're looking for both 12 and 16. Now there are a lot of ways to do this. You could just take the biggest number and start listing multiples of 16, go 16, 38, or 32, 48, and so on until you find a number it's going to work for 12. And on some of those, intuitively, that might work really nicely. Other times it's a little trickier, and that listing method that we just described, that might take longer than you want. So there's a way to use prime factorization to find an LCD or an LCM. If I take prime factorization, that means I'm going to start with my 12, and I'm going to ask what are some factors, not even prime factors, but any two factors which multiply together to get me 12. I can do 2 and 6, 3 and 4, but I don't want to do 1 and 12 because 1 and 12 just kind of loops me back around and takes me right back to the same place where I started. So I'm just going to arbitrarily pick 3 times 4. Now the way I do this is it helps my brain and my eyes to see which numbers are a stopping point in this process when I circle them. And what I'm looking for is this. I want to find any of these numbers that are prime. So 3 is prime, I'm going to circle that. 4 is not prime, it's composite, so I'm going to continue looking for yet another way to break that down. So 4 is going to break into 2 times 2. Those are both prime, so I'm going to circle both of those. Can you see that every branch now has a circle at the end of it, which means I'm done breaking this down. So I've got 12 is equivalent to 2 times 2 times 3. When I do the same thing for 16, again, you've got a lot of options. You could go 4 times 4, or you could go 2 times 8. It's totally up to you what you want to do. I'm going to go ahead and use 2 times 8. Now, I'm asking myself again, is either of these prime? And sure enough, we see that 2 is prime. But 8 is composite, so we want to continue breaking that down. 8 breaks into 2 times 4. So I'm going to say 2 times 4, circle the one that's prime, keep working on the one that's composite. It doesn't really matter which choices you make. Honest to goodness, you're going to end up at the same place at the end. So 4 is composite, and I keep going. 2 times 2, both of those are prime, and I can circle them. This is the full prime factorization of 16. It's just really a boatload of 2's, right? So I'm going to write that down. I'm going to say 16 is the same as 2 times 2 times 2 times 2. Now remember what we're looking for. We're looking for a least common denominator or a least common multiple, but one of the main things you want to look at is that these have to have common something. In this case, it's going to be common factors, right? So in order to find the least common denominator, or the LCM, what I want to start by listing is anything that would be a common factor between the two listings that we've gotten. Now, common factors would be, look, same factor, right? So I'll list 2 just once. There's another common factor of 2, which I will list just once. Look at what's left over here. All I have left is a 3, a 2, and a 2, and nothing's common there still. Now, hold on, somebody usually says, I still see 2 2's. And while that's true, the thing is, it has to be a least common multiple or least common denominator built from both the 12 and the 16. So while we do still have 2 2's, they're not sourced from different numbers. The 2 2's are both sourced from the 16, so they don't really count right now. When you're building the LCD, you want to list all the common factors first. You want to multiply those by what I sort of sadly refer to as the leftovers. And you literally are just going to check to see what's left over in your list. I've got a 3, a 2, and a 2. 3, a 2, and a 2. So I just bring those on board. You're going to want to go ahead and grab a calculator or multiply these in your head. You can go in any order you want. And so when I'm doing this, I can go 2 times 2, and that's 4. 4 times 2 is 8. 8 times 2 is 16, and 16 times 3 gets me an LCD of 48. I could go in a totally different order. Like if I just wanted to go straight across, it would be 2 times 2 is 4. 4 times 3 is 12. 12 times 2 is 24. 24 times 2 gets me the same 48. So you can arrive at it different ways, but we should all end up in the same place. So this is the way we find an LCD with just 2 numbers that we're working on. Now, we're not always working on 2 numbers, and in fact, the email that was sent to me today that made me say, oh, I've got to do this video, let's see if that helps, was for these 3 numbers. Look, we're trying to find the least common denominator or the least common multiple, same thing, 4, 16, 8, and 9. Now we start this process exactly like we did the last problem. So what I'm going to do is take 16 and find its prime factorization. This time I'm going to go 4 times 4. Now neither of those is prime, so I have to break both of those up still. These break into 2 times 2. 2, of course, is the only prime even number, so I'm going to circle each of those. And then the other 4 breaks similarly. Gets me a 2 and another 2, and I circle both of those. So 16's done. It's just a whole bunch of 2's. I've got 16 is the same as 2 times 2 times 2 times 2. Okay. Now let's take 8. To get its prime factorization, let's ask ourselves, well, what times what gets me 8? And of course, that's 4 times 2. And I can break up the 4. 2 was prime. That gets me 2 times 2. And so I can say the prime factorization of 8 would be 2 times 2 times 2. And this was a 3-number LCD, so we want to bring on board now our 9. 9 only breaks up one way. I mean, we're not going to use 1 times 9 because, again, it's not helpful. 1 times 9 still makes us work with the 9, and we don't want to do that. We can break into 3 times 3, and if you think about it, 3 is prime, and so we get to say that this is done. Prime factorization for 9 is going to be 3 times 3. Now to build our LCD, we still want to look for anything that's common, and a bunch of folks are like, oh, wait a minute, I don't see anything common between all 3 lists. And that's true, but you know what? That's okay. We're still just looking for numbers that would be common between any 2 rows. So right here, can you see that there's a common factor of 2's? So I'm going to list that just once. In fact, there's another pairing. Look, look. Boom. I got another one. So I'm going to say times 2. But I'm still not out. Can you see that there's another pair of 2's that are still common? And it's at this point that I go, oh, wait a minute, I'm completely out of things that are going to match between one row and another row. So I've got my prime factors listed here, which are pairs, your matches. And now I want to bring on board my leftovers. And what's that going to be? That's going to be this 2, that 3, and another 3. Now I can multiply this in any order I want, but essentially what we're going to do is 2 times 2, which is 4, 4 times 2, which is 8, 8 times 2, which is 16, 16 times 3 gets me 48, and I go 48 times 3, I get 144. So my LCD is 144. The other way you could do this is, I mean, more like sort of brute force. You could take the biggest number, 16, and just start listing multiples of that. So I'd go 16, 32, 48, 64. Start comparing those numbers, those multiples, with the 8 and the 9. Remember, if it's a good multiple for all 3, you'll be able to divide your LCD by each of the given numbers to begin with. It's not going to happen when you're doing the listing method until you get all the way up to 144. So sometimes that idea of just listing all the multiples of the bigger number, it takes a while, it's not very efficient. And you might be thinking, oh, I don't know if I've got the right one. If you do the factor tree method, you're going to end up with the least of the common multiples, and that's really what you were looking for. I sure hope this helps. If you have more questions, you can email me, and I'll catch up with you later.